Hello, welcome to part 2 of the Info2K Data Engineering for AI series. In part 1, we covered the hidden data engineering behind a successful AI project. We showed that AI solution is never only a model. It depends on the pipelines, data control, quality control, monitoring, retrieval, metadata, security, and the person who operates the system. In this video, I'm going to examine a phrase that is now used everywhere, AI-ready data. It sounds simple, but we cannot find a clear definition for it. Does it mean the data has been cleaned? Does it mean the data is available in cloud? Does it mean the AI model has accessed it? Each of them, they may be useful, but none of them is enough on its own. So in this presentation, we're going to cover and explain that what does it mean, the AI-ready data? And data is going to become ready only when it's fit for an AI, a specific purpose. So it means that it should has a good quality, accessible, have a currency, governance, security, and operational support, and etc. So by the end of this video, you should be able to have a practical framework to assess if the data is ready for AI project or it's merely available for an experiment. Be with me in this video to see what's the AI-ready data means. Let us begin by separating AI-ready data from clean data. Cleaning normally focuses on defects, using values, duplicates, incorrect formats, invalid codes, or inconsistent records. These are important issues, but readiness asks a broader question. Ready for what? A dataset can be clean and still be irrelevant to the intended use case. It can be complete but several months out of date. It can be accessible to an AI system but lack the permission needed to protect sensitive information. It can be accurate at the field level while missing the business or clinical context needed for correct interpretation. IBM describes AI-ready data as high quality, accessible, and trusted information that an organization can confidently use for AI. Microsoft's governance guidance adds that trusted data should also be discoverable, accurate, and protected. Notice how both descriptions move beyond cleaning. They include access, trust, governance, and protections. So instead of asking, have we cleaned the data or can the model access it, ask, is this information suitable for this AI use case, for these users under these risks and operating conditions? That question produces a much more realistic readiness assessment. This slide summarizes 8 characteristics that work together to create AI readiness. First is purpose. The data must be relevant to the task the AI is expected to perform. Second is quality. It must be accurate, complete, consistent, valid, and timely enough for that task. Third is context. Definitions, units, ownerships, source, effective date, relationships must be understandable. Fourth is access. Authorized team and systems must be able to discover and retrieve the data through reliable interfaces. Fifth is currency. The system must distinguish current information from historical or superseded information. Sixth is governance. Privacy, security, consent, lineage, retention, and permitted use must be enforced. Seventh is evaluation. Data must represent realistic situations, including difficult, ambiguous, and high-risk cases. Finally, operations readiness must be maintained through monitoring, ownership, alerting, and remediation. This framework draws together the recurring themes in IBM and Microsoft guidance: quality, accessibility, trust, metadata, governance, security, and ongoing management. No single characteristic is enough. High quality data without context can be misunderstood. Accessible data without governance can create exposure. Governed data that is stale can still generate incorrect outcomes. AI readiness is therefore a property of the complete data system. This is why clean data can still be unready. Imagine a repository containing company policies. Every PDF has been extracted correctly, there are no duplicated files, and the text is searchable. Technically, the data looks clean. But what if the repository contains policies that have been superseded? What if the AI cannot identify which version is authoritative? What if regional policies are mixed together without location metadata? What if every employee can retrieve confidential HR material? The technical cleaning was successful, but the data is still not ready for a trustworthy policy assistant. IBM highlights several common barriers to AI readiness, including fragmented data, poor quality, operational bottlenecks, and governance or security risks. The practical lesson is that defects are only one category of risk. The 5 boxes on this slide show other failure modes. Data can be clean, but irrelevant to the use case. It can be stale because no current version is identified. It can be uncontrolled because access rules are not enforced. It can be unobserved because nobody monitors what happens after deployment. Readiness fails whenever purpose, context, governance, or operational ownership is missing, even if every field passes a cleaning rule. AI readiness must remain operational because data never stays still. Source system change, schema evolve, new records arrive, documents are replaced, business definitions change, permissions are updated, user behavior also exposes situations that were not present in the original test data. This is why the wheel contains 8 ongoing characteristics rather than 8 tasks we complete once. Relevance can change when the business objective changes. Accuracy can deteriorate when an upstream integration fails. Context can be lost when new fields arrive without documentation. Accessibility can fail when an API or pipeline changes. Currency depends on refresh and version management processes. Governance must respond to new users, policies, and regulations. Representation may shift as the real population changes. Observability tells us when these problems begin. Microsoft's guidance on data quality threshold is useful here. It explained that good enough should be defined for the specific use case. A descriptive field may tolerate some missing information, while a safety critical or financial field may require an extremely strict threshold. The important point is not the exact percentage. It is that expectations are explicit, monitored, owned, and connected to action. AI ready data is therefore not a finished dataset. It is a maintained organizational capability. Readiness starts with a defined use case because the same dataset may support one purpose and be unsafe for another. Consider a hospital dataset containing diagnoses, medications, laboratory results, and clinical notes. For aggregated monthly reporting, the organization may accept a delay and some missing descriptive fields. For predicting service demand, the data may need consistent history, stable definitions, representative time periods, and protection against leakage from future events. For an assistant supporting an individual patient care, the requirements become much stricter. Patient identity must be correct, current and historical information must be distinguished, access must be appropriate, and source evidence must be available for human review. AWS Generative AI Workload Assessment Guidance encourages organizations to ask which data types are crucial, how much is accessible, how quality is measured, and which governance practices are in place. These questions are valuable because they connect technical preparation to the actual workload. Before declaring data ready, ask 6 things. What is the purpose? Who are the users? What decision or action could follow? What is the risk if the system is wrong? How current must the information be? And what evidence must the system preserve? Without those answers, AI ready has no stable meaning. Structured and unstructured information need different preparation because they fail in different ways. For structured data, we normally begin with the schemas, data types, valid range, relationships, keys, timestamps, and business rules. We may need to standardize units, resolve duplicate identities, align events in time, or confirm that labels genuinely represent the outcome being modeled. Unstructured information creates different challenges. A PDF may contain several sections with different meanings. A clinical note may include negation, uncertainty, abbreviations, and historical statements. A policy document may be one of these versions. For these sources, preparation includes text extraction, document classification, deduplication, chunking, metadata enrichment, version management, and permission inheritance. The word link on this slide is especially important. Records and documents need to remain connected to the correct customer, patient, product, case, or business process, and retrieval must be evaluated. It is not enough to generate embeddings and confirm the search return something. We need to know whether it returns the correct, current, authorized evidence for realistic questions. The preparation method must therefore match both the data types and the intended AI use. RAG provides a practical example of why AI-ready data means much more than embeddings. The process begins with ingestion. We collect documents from approved sources and preserve their origin. Next, we classify them so the system understands document type, subject, owner, audience, and sensitivity. We remove duplicates and superseded versions. Then choose a chunking strategy that preserves enough surrounding meaning. Metadata enrichment adds context such as department, effective date, version, classification, and access rules. Security must be enforced during retrieval, not only in the user interface. An authorized passage should never be supplied to the language model. The index must also refresh when documents are changed or deleted. Otherwise, the AI may continue retrieving information the organization no longer considers valid. Finally, retrieval needs evaluation. Did the system find the best evidence? Did it return irrelevant or conflicting chunks? Did permissions filters work? Did it correctly recognize that no approved answer was available? AWS describes using metadata filters for departmental permissions, sensitivity classification, tenant separation, and time-based controls. This shows why metadata is not decorative. It actively shapes what the AI is allowed to know in a particular interaction. Healthcare raises readiness threshold because errors can affect privacy, trust, and safety. Imagine an AI assistant asked to summarize a patient's current clinical situation using notes, laboratory results, medications, diagnosis, and discharge summaries. Before generating anything, the system must confirm that the records belong to correct patient. It must distinguish current medication from discontinued medication and an active diagnosis from a historical or suspected condition. Clinical language adds further complexity. A note may say that a condition was ruled out, that a family member had it, or that it was only being considered. Keyword matching alone can easily lose these distinctions. Time also matters. The date a note was written may be different from the date of the clinical event. A result may have been corrected. A discharge summary may supersede an earlier plan. Privacy and access controls must operate at retrieval time, and the final output should retain evidence so a qualified person can verify it. The lesson is not that AI cannot help in healthcare. AI can be valuable for finding, organizing, and summarizing information, but the data and workflow must be designed for assistance, verification, and human accountability. In high trust domains, data readiness is part of system safety. A demo-ready dataset is not necessarily production-ready. A successful demonstration may use a small, carefully selected sample. The team may manually correct documents, check outputs one by one, and restrict access to a few project members. Under those conditions, the results can look impressive. Production introduces a different environment. Data arrives continuously, users ask unexpected questions, upstream systems change, permissions vary, quality issues may affect thousands of interactions before anyone notices. That is why the right side of the slide adds 5 production requirements. The purpose must be clearly defined so success and failure can be measured. Quality thresholds must be explicit. Access must be governed and enforced. Monitoring must continue after deployment, and ownership must be clear when something goes wrong. Microsoft's threshold guidance explains how measurable standards create accountability and easy detection. AWS assessment guidance connects readiness to accessibility, quality measurement, governance, and stakeholder trust. Together, these sources reinforces an important distinction. Production readiness is not achieved by making the demo larger. It is achieved by making the system controlled, measurable, observable, and maintainable. This presentation is part 2 of the Info2K Data Engineering for AI Learning journey. Part 1 established the foundation. Successful AI depends on the data engineering system behind the model. Part 2 has taken the next step by defining AI-ready data as data that is fit for a specific use case and supported by quality, context, governance, accessibility, currency, evaluation, and operations. In Part 3, we will compare ETL and ELT for modern AI systems. We will examine where transformation should happen, how could platforms have changed the decisions, and why the answer depends on governance, performance, reuse, and workload requirements. After that, we will explore reliable RAG pipelines, data quality for AI, healthcare NLP, responsible AI, cloud platforms, and modern data engineering. The intention is not to create a collection of disconnected definitions. Each part builds on the previous one. Together, the series explains how raw information becomes trusted, governed, contextual, and reusable knowledge, and how that knowledge can support practical AI systems. Let us finish with the central takeaway. AI ready does not mean perfect data. No real organization has perfectly complete, perfectly current, perfectly documented data for every possible use. Readiness means that the organization has defined the intended purpose and can demonstrate that the data is sufficiently reliable for that purpose. The quality expectations are known. The meaning and origin are understandable. The information is current enough. Access is authorized. Sensitive data is protected. Evaluation reflects realistic conditions. Monitoring and ownership continue after deployment. So, when somebody say, we need AI-ready data, the next question should be, ready for which AI use case? The question changed the conversation from a vague technology ambition into an engineering and governance problem that can actually be assessed. In Part 3, we will build on this foundation and look at ETL versus ELT for modern AI systems. What changed when transformations happen before or after loading, and how organizations can choose an approach that fits their platform and use cases. If the explanation was useful, please subscribe to the Info2K YouTube channel. The next video will cover ETL versus ELT for modern AI systems. We will then continue with practical discussion on RAG pipelines, data quality, healthcare NLP, responsible AI, cloud data platform, and modern data engineering. The goal is to explain not only what these concepts mean, but how they work together in real production systems. Please follow the Info2K LinkedIn page as well. On LinkedIn, we will share the complete articles, shorter practical insights, diagrams, discussions, and announcements for each part of this series. We will also share updates about the future applications and solutions we are developing across data engineering, AI, and digital health. If you have experience preparing data for AI, I would be interested to hear your perspective. Which part of AI readiness do organizations underestimate most? Quality, context, governance, operational monitoring, or something else? Thank you for joining the Info2K on the journey from information to knowledge.